I think I'm going to say good morning to everyone. I think we got a little bit of our background planning there. Maybe we can edit that. I'm not sure. Anyway, my name is Stephen Hoffman. I am the principal of Compass Natural and very happy to host you today and be a part of this exciting panel. I want to thank my colleague, Allison Oliver Salvati, for helping put this whole program together. And we are very honored to be a part of the USDA Transition to Organic Partnership Program, which is a unique program of extension education and presenting resources to farmers curious or interested or pursuing transition to organic agriculture, because there are some challenges there. There are a lot of questions. And yet in that transition, we do see and want to convey environmental and economic benefits that are also associated with this. One thing that we know is we welcome our speakers today, and this session is focusing on the use of technology in agriculture, and it's particularly important for all of us in our everyday lives. Technology, culture, and humanity, we kind of have all evolved together, and technology is not bad. It's good, actually. It depends on its use. One of the things I learned when I was a Peace Corps volunteer long ago was the use of appropriate technology. And what is appropriate in organic agriculture? Well, you'd be surprised. It can be from mini robots in the field to drones in the sky to flamethrowers that can help reduce weed populations, because organic farmers have to rely on mechanical and other means versus just toxic synthetic pesticides as the main go-to for pest control. I want to welcome our speakers today, who are all specialists in this field, experts and innovators, really from the ground up, literally, in organic agriculture. And I want to introduce those folks. Sarah Hinckley with Barn Owl Precision Agriculture. Hi, Sarah. We learned of your work literally, helping organic farmers, conventional farmers, farmers in organic transition make use of, and I really like that term, precision agriculture, because you are the one who's going to speak of the use of mini robots in the field, drones in the sky, to monitor fields and micro monitor fields like never before. So we're really excited to have you talk more and present a little information about that. We also have Haley Nagel with us, who works with, it's actually this unique partnership between Colorado State University and USDA's Natural Resources Conservation Service. It's called Comet Farm. They're using detailed location-specific data on climate and soil conditions to help farmers measure, track, and improve the carbon percentage level in their soil. The more carbon in the soil, the healthier the soil, the less CO2 in the atmosphere. So Haley's work is really important, and we want to continue to emphasize that organic soils actually sequester more carbon in the soils, and according to the Rodale Institute, can be very effective in helping mitigate the planet's climate change challenges we have today. Last but not least is a friend, a colleague, a gentleman I greatly admire, who I met through the industrial hemp marketplace, attending NOCO hemp expos. And the trade show hall always had to make huge room for the cultivation, the tractor, the harvest equipment that Bish Enterprises brings to the table. So literally cutting edge, innovative tractor and harvest equipment that farmers absolutely need on the field. And Andrew, right now, when he mentions that he just mentioned earlier that he's very busy with the harvest this year, that's very literal. Are we toward the tail end of that harvest, Andrew, or are you still pretty much in the heart of it?
Well, I think we're probably about 65% of the way through with corn harvest nationwide. We're starting to see sorghum harvesting just getting underway, and sunflower harvesting in some places. So usually we see this run through about mid-December before it all gets to close down. So a little ways left to go before we hit the finish line.
So, like tax accountants, this is your season right now where you're really busy. So, thank you for taking the time to join us today. So, again, I want to thank the folks that help enable this. Our partner, OCIA International, which is administering the Transition to Organic Partnership Program in the Plains States. A little bit about TOPP before we get started. It is a unique program driven by U.S. Department of Agriculture's Agriculture Marketing Service, the National Organic Program. And again, it's to encourage farmers to consider transitioning to organic agriculture. Only a small percentage of our acreage in the United States is organic, but it makes a huge difference. With that, I'd like to turn the floor over to Sarah Hinckley to present to us a little bit about her background and her work with Barnow Precision Agriculture. I just love the name of your company. Sarah, also congratulations. I believe you're adding to your family. So we want to thank you very much for taking the time with us today as well. Take it away.
Thank you. Yeah, and thanks for having us. We're happy to be here and excited to share what we do. So I'm Sarah. I'm the CEO and co-founder of Barnow Precision Agriculture. And we got started originally in 2018, 2019, just flying drones over farm fields to help growers explore areas of opportunity. So identifying irrigation leaks, maybe opportunities for replants, insects and disease identification. And as we were doing that, our growers said that the information in the maps are really fantastic and we need this, but without some sort of system to go and solve these problems, we can't really use one. We need them both. And so in 2021, we decided to explore introducing autonomous farm robots, which we call autonomous nano tractors. And today we use the drone systems as a kind of mapping system for the robots, and then the robots go out and perform a task. These systems are built on soil health, on positive soil health aspects. So they are lightweight. They are designed to fit in 24-inch rows or larger. So we have two different versions, a 24-inch robot and then a 30-inch robot. They tow one implement that has different mechanisms on it. So mostly no-till or reduced till. They do cutting, they do really low or subsurface digging for in between the plants for weed control. And then they also can precision spray. We will add soil sampling to have a more holistic field approach for soil testing and soil measurements. And then they also provide harvest support. So in a few years, they'll be able to precision harvest, but today they can tow your harvest labor behind the robot and allow that human energy to be saved a little bit better. So the harvest team can spend a little bit more time in the field and not be as exhausted. This is a labor alternative. The unit can work in day, night, and extreme heat, and it's easy to obtain by just giving me a call. So the best thing about this is that we do this as a service. So it is lower risk for growers who just want to try it on 1 or 2 acres. And there isn't a large capital investment. So as a service, we do it as a per acre basis, and then you can decide how many acres you want or how many acres you don't want. So you can kind of see that original prototype of the implement. It's 3 rows, so it can do 3 rows of different tasks at one time. The design for that is to be able to grow, 3 different rows of 3 different crops and be able to manage those different rows of specific inputs or specific control methods for the timing on each specific row. On the other side here, you can kind of see a before and after picture of a no-till, reduced till approach in an orchard. That one is here in Canyon City, and we work throughout Colorado and then in other states as well. This one here is just a kind of a picture of a before and after of a Colorado State University demo. This is broccoli that we were operating in. And you can just kind of see the reduced till approach on the left there. And then the right-hand side is another kind of farm robot. And there we're just showing the size. So in it being much smaller, we have virtually no soil compaction, and we can also operate in wetter conditions so that the lightweightness does not allow us to sink into, if you're watering, we can get through a sprinkler, we can get through your drip during your water, so you don't have to work around us. We work around you. So again, it's weeding is our focus in 2023. And so that's a no-till, reduced-till approach from cutting to light digging. We do have some cultivation tools, so it's really just up to a specific farm and the specific crop on what should be used at what time. We have spray, and so the way that works is we just tow a sprayer, and then based on the applications that you decide as the grower, we can put specific spray on basically the root of the plant is what we're looking for, but however you need it adjusted is how that implement works. Eventually we'll be able to do broadcasting and soil sampling, and then we do the harvest support, and we actually do already plant right now. And so we will continue to develop and grow these specific tools based on whatever the grower decides. Our biggest thing is just making sure that we're working with the grower as the manager. So the grower decides everything, and then we just go out and perform the tasks as a support system. This is a sugar beet that we grew on all organic methods in 2023. So pretty exciting here. This was a no-till, no input, pretty much organically grown sugar beet here in southern Colorado in the San Luis Valley, actually. So we did deploy robots, we planted, we did weed control, and we did precision spraying. And then each of those 30-inch units can tow up to 1,000 pounds with all four of that's only with 2 wheels, but with all 4 wheels working, it can tow 2,000 pounds. And so that's just to increase the amount of organic applications that can be sprayed for the entire plot. This is a photo of, again, another before and after picture. So on the left here, it kind of looks like the weeds have definitely outgrown any of the crops, but using our systems, our drone analysis, and our robots, the combination of the two, we were able to go in and provide the precision weed control in between the plants, and then clear it out so that those crops did actually have a chance to grow and survive this season. We grew sugar beets. This plot also has some peas and green beans, and then some oats on the side there. And then in that picture on the other side, that is just a photo of kind of the rockiest soil that we operated in this season. So we can manage many different soil types and use our applications to work through kind of whatever challenges our organic growers are facing. This is just the difference in the size of the 2 units. So the big one and the little one just kind of depends. The little one is more for late season applications. So when your corn gets tall, sweet corn, organic corn, or any other tall crops, we can go in between the rows. For anything else that stays kind of low, sugar beets, soybeans, any other, smaller to the ground plants, we can use the larger one to just go over it all season. This kind of talks about the way that we show up, basically. So we have an operations container. We drive to your field. We deploy the robots. The drone does a flight. We incorporate a spray drone for late season, melons, pumpkins, things that we can't get the robots in because they'll squish the crop. So we can incorporate a spray drone as needed. And it's a pick and choose system. So you can decide what you need and when you need it. This is some of the drone analysis. So the drone systems are incorporated to identify irrigation events, identify where the weeds or the pests or any other concerns are, and then we send the robots to go out and manage those specific challenges. Kind of the unique thing about this is so when we identify that you have an irrigation leak or something else going on, the robots can go and perform the weed control, and then you can send somebody else, your tractor operator or somebody else, to go and fix that irrigation problem. And that's just vital because then you don't have to wait till tomorrow to fix one or the other. You can solve both of those challenges right there and then have a clean kind of peace of mind going forward to the next day. This is some more of the drone analysis, so identifying the crop health, but we also use this in our vision systems to identify the rows and the counts of the plants. So we do plant counts, which allow you to decide if you want to replant your field or do any kind of other specific inputs. If you're not happy with your population in one area, maybe go in and spray a specific organic compound or whatever else it might be. Another one just of the broccoli. Showing here the drone analysis and the imagery, the quality and the detail that we get from this drone imagery. This is just some of the additional drone applications. So counting in this middle photo here, you might be able to, but there is a worm in this ear of corn. And so identifying this worm or this insect before it goes in and is able to destroy your entire crop. It's all about timing. And so if we can get in and identify this before it takes over, then we have a better opportunity to solve these challenges that our organic growers are facing. And for barn owl, I would say that the biggest thing is that it's not about the specific robots or the specific drones. It's about collaboration in the system, being able to work together, with Andrew and with Haley on Comet and Bish Enterprises, and figure out what systems using the combination of everything are the best approach. We are not intended to replace the tractor because with the small farm robots, we'll never be able to compete in speed or the long implements. But for small farms, mid-sized farms, or really heavy polyculture farms, this system is a great supplement. And as long as we have the growers by our side to help navigate, the future of ag, then we definitely can make a difference, and be happy to answer any questions at this time.
I've got some questions for you, Sarah. I think it's fascinating, the work that your company is doing. It's a service-based model, so you kind of come in and, I can remember folks coming in. Well, it's almost like someone coming in with their beehives to help pollinate, or someone coming in with their sheep to help control weeds in orchards. You're coming in with like a little stable of robots. So my most important question is, how come teal and fuchsia as the colors?
The hot pink is for high vis for sure. So using that hot pink, we need that visual identification from the air. Hot pink isn't often found in any other crops, and so that was the reason for that. And then as far as orange and some other colors are already taken. So we found hot pink, and we're probably the only pink robots in the industry at this point.
I knew there was a reason more than fashion. Yeah, but yeah. Hey, Barbie robots at this point, right?
That's right.
So again, the service-oriented business, that's interesting to me. And then can you speak to any particular cases of where farmers in organic transition, as we're focused on that, might and I love that you're for small and medium-sized farms, and that is where a lot of farmers considering transition to organic may be. So can you speak a bit to that specifically?
Yeah. So the service approach is because we want to avoid offloading this software and these vision systems onto farmers when there's so much room for continued development. As the units and the vision systems become a little bit more stable, I would say there is an opportunity for purchasing of the equipment for larger growers, but I don't think that's we'll always have both options. The service aspect also just allows us to keep the prices low. So we start out at $55 per acre, as opposed to a farmer having to spend, $250,000 on a piece of equipment that may or may not only be used 3 or 4 times throughout the season.
Are you manufacturing your own robot? I mean, and you're probably modifying drones.
Yes. Yeah. So we do manufacture these. Everything is manufactured in La Junta, Colorado. The reason for us to manufacture is mostly because of the supply chain and the ability to keep everything close to the field. And so we can manufacture a robot in 2 to 3 days, deploy that robot, scale up and down as any grower is needed. And then the manufacturing also allows us to create custom implements. So let's say that a grower needs a specific implement. We can go in and create a design, have that design built, and then get it out into the field, within a couple of weeks to make sure that we're having the most effective possible solutions for growers who often always have the same, they have the similar needs as far as, I would say, implements go. And then the additional, I think, Steve, there was a second question in there if you wanted to.
Just, anything where particularly the farmers that are in transition organic, where the value of your systems come in.
Yeah. So transitioning to organic, this system is built, it's lightweight. So you have the soil health aspect. It is no till, it's low cost, it's less risk. So, in making all of those decisions to transition to organic, this solution just allows you to have a little bit more peace of mind in making that transition. As far as the certification process, we can definitely assist in the proof of that. So all of the applications that are done on our end, we have the drone imagery, we have the robots that show the techniques that are being done as far as being a certified organic grower. And so whenever you're ready to transition to organic, there is some concern of, how hard is this going to be? How much time is this going to take? And so implementing the robots and the drone systems just allows for a little bit smoother transition, I would say.
I think it's fascinating stuff. Thank you so much for presenting. And I believe you're also going to be participating in our live event at the Colorado State University Spur campus in Denver on November 9. So look forward to meeting you in person and hearing more about this real innovative stuff, which I also noted that you're looking a lot at no-till and reduced till, again, ways to sequester carbon in the soil. I really liked that example of organic sugar beets because I know sugar beets are such an important crop in the Plains states and in particular in Colorado. So thank you again. Any final thoughts before we turn to our next speaker?
I'm, just happy to be available if anybody has any questions or comments, or if you want a field demo, just holler and we'll be there with some autonomous nano tractors or farm robots.
What's your website again?
barnowlag.com, and my email is sarah@barnowlag.com. We are not marketers, so our website is a little outdated. We prefer to spend time on the farm, honestly. So
and that's really wonderful. Again, thank you for taking the time with us today. Our next speaker, we're going to move on, is Haley Nagel. Haley conducts lead outreach for Comet Farm, which we mentioned a little bit earlier, is a unique tool developed by Colorado State University and the USDA Natural Resources Conservation Service, using detailed location-specific data on climate and soil conditions. Comet Farm helps farmers estimate the carbon footprint for all or part of a ranch and farm operation, allowing operators to evaluate options for reducing greenhouse gas emissions and sequestering carbon in the soil. So this is a really important tool that can help farmers reduce their footprint and also net sequester carbon in the soil. Haley, thank you very much for joining us today. And if you would like to present.
Thank you so much for that introduction. And Sarah, that was a great presentation as well. I think we've communicated a few times in the past as well. Can you guys see my Comet Farm Comet Planner screen? Awesome. So like Steve said, my name is Haley Nagel, and I'm the lead outreach specialist for the Comet Farm team at Colorado State University under the leadership of Dr. Keith Paushin. And so in this initial presentation, I'm going to talk about greenhouse gas emissions related to agriculture and Comet Farm. And then we'll dive into Comet Planner, the simpler of the Comet tools, I will show you how you can access Comet Farm and the upcoming trainings that are associated with that as well, which there is one going on right now as we speak. So I am presenting on behalf of my team on the left, and I would always like to extend a special thanks to NRCS and the U.S. Department of Agriculture Climate Change Office for their continued support and funding for the Comet tools. So right now, we have quite a few users of both the tools. However, we do have our more popular tool is Comet Planner, which is what I'm going to show you a live demo after these few slides. As Comet Planner is easier to use, it only takes 4 steps to get your estimate for your soil carbon reduction or your greenhouse gas emission or soil carbon changes and your greenhouse gas emission changes as a result of conservation practices that you might implement. And a few of our users are NRCS officers and around the nation. We have scientists who are using it. We have quite a few farmers that are using it, and conservation planners who are working in conjunction with those farmers, as well as educational institutions like CSU, but all over the nation as well, which a few of those are included in our quarterly newsletters, which anyone can sign up for those. And we feature some of those users who are excited to share how they're using the tool. And Comet Farm and Comet Planner is really a nexus for greenhouse gas mitigation in agriculture. You may have heard of the Partnership for Climate Smart Commodities program that USDA is sponsoring, and multi-billion-dollar project where applicable, any of those projects are required to use the Comet tools in some capacity. And then there are various state and other federal level programs that are using Comet Farm and Comet Planner as the official greenhouse gas accounting tool of USDA. I would like to mention that Comet Farm has been used by carbon registries and carbon credit companies. However, we are entirely separate. We do not offer any advice on carbon credits. We do not, it is not a carbon accounting tool for offering carbon credits. So if you have any questions about that, that is in the wheelhouse of carbon credit companies. And all of the data that is used that a user would input in any of the Comet tools is private for any of those. You as the user are the only one who has access to that data that you enter. So I know that is an important feature for a lot of producers, that you are the one who owns that data. We do not have access to that, nor does USDA, nor do any of the other users. So we are going to focus on Comet Planner, but you can also access Comet Farm for free. All of these tools are 100% for free for all users when you're using the interface, the website that we're going to look at today. So where did it go? Let's see, there we go. I don't know why that freaked out for a second. Let's open on full screen. There we go. So, wow, it really doesn't like that slide. Okay, we'll just keep it in here. Odd. So we're going to look at what Comet Farm is actually looking at. And Comet Planner, because Comet Planner accesses Comet Farm, we're going to look at, they look at the same thing. And Comet Planner is mostly focused on cropland, grazing land accounting. We also have woody planting accounting in there as well. But for the crop associated practices, we're looking at the top 30 centimeters of the soil to assess for any soil carbon changes or any greenhouse gas emission flux associated with your practices. And so an example that I like to show is on a demo project that we include in the tool. This producer switched from intensive to no-till on 60 acres of corn soybean rotation in Iowa, and that resulted in 52 metric tons of CO2e reduction annually, which is the equivalent of removing 11 passenger vehicles for a year, the emissions associated with that. And so these are the types of values that you can get out of Comet Farm and Comet Planner. And so Comet Farm is designed to do an entire greenhouse gas inventory within an entity. And Comet Planner can also do that, except we are limited on, there are not as many animal agriculture associated practices in Comet Planner. But we are looking at the flux between soil carbon, CO2, methane, nitrous oxide in Comet Farm. And then Comet Planner is going to be focused on CO2, soil carbon, and nitrous oxide fluxes. The methods that are implemented in the Comet tools are aligned with the USDA peer-reviewed methods and models in this hefty methods document that is currently set to be really a new updated version is set to be released at some point this fall, fall/winter. So as soon as that is available, we will post that on all socials and it'll be blasted on the website. But these peer-reviewed methods and models that are outlined in the Blue Book document are going to simulate those greenhouse gas fluxes within your defined entity, which is the fields that you define in Comet Farm or the animals that you define in the animal agriculture section. Comet Farm assesses the soil emissions from DACENT, which is a daily time step process model. And then we also have other empirical models to assess livestock emissions, as well as a separate tool to assess energy-related emissions, because Comet Farm is not a life cycle analysis tool. We are looking at just within the farm gate. And so what Comet Farm and Comet Planner will do, they are similar tools in that they are both set up for conservation scenario analysis. So a user would define some sort of baseline in Comet Farm. This is your current management. In Comet Planner, you're picking from a list of business as usual scenarios, like if you're in an intensive till scenario and you'd like to switch to a no-till scenario, that intensive would be your baseline. And then in both tools, you indicate some sort of change in management. In Comet Farm, that is going to be specific to your field. In Comet Planner, this is going to be also specific to your field, but you're picking from a set list of 34 different NRCS conservation practice standards that are tied to soil carbon reduction or greenhouse gas or soil carbon increase and a greenhouse gas emission reduction. And then you will get, in Comet Farm, you'll get a practice benefit compared to your original emissions or soil carbon. And then in Comet Planner, you'll just get a practice benefit because it is an easier tool to use and just designed for planning purposes. Comet Farm is if you really want the nitty-gritty details of your specific fields. So Comet Farm does take a lot more time and information to run. Which is why we're not going to look at that today. We're going to be focused on Comet Planner, which provides regional average estimates of those practices implemented in different regions around the US. So all you need to know is a state, a county, and what conservation practice you'd like to apply, and how many acres you'd like to apply it to. So it does only take 4 clicks to generate an estimate, and you can download that report. And if you're feeling very adventurous, you could also download the entire data set that is behind the Comet Planner tool. So you could do your own manipulations of different counties and finding aggregate data, whatever you would like to use it for, that is available for use. And so I am actually going to skip these next few slides, since I'm running low on time, and go to what Comet Planner, how the data set behind Comet Planner was created. And so the team, prior to me being on the team, we took about 100 random cropland and grassland points within each of the 230 major land resource areas around the nation. And then we built crop rotations using a cropland data layer from NASS, and then adding typical planting crops and harvest and planting dates and typical fertilizer rates and application dates based off of each of those regions. And then we are running that through the Comet Farm API, which is kind of like a backdoor entrance to all of those methods that are defined in that Blue Book document that I mentioned. So we're using all of the spatial data. So Comet Farm uses the Surgo soil data, which is mapped for the entire lower 48. And then we're also pulling in PRISM weather data for each of the regions, actually on a county level. So Comet Planner is still using all of the same methods, models, data sets underlying Comet Farm in order to provide you with, well, I don't want to, I'm going to spoil it. I'm going to spoil it. So I'm going to stop here and I'm going to show you the actual tool, what Comet Farm actually, or Comet Planner actually provides you. So to get to Comet Planner, it's a simple comet-planner.com. And you will be prompted to enter your project name. So we can say test or sample or whatever you'd like to name it. We're going to select a state or county. I am in Colorado. And I'm going to select my county, which is where CSU is located, Larimer County, up in Fort Collins. And then you can select your class of conservation practice standards. This is just to organize what you're going to select down below. You can also select as many or as few as you'd like. We'll start with one. So I'm going to select cropland management, and maybe my most frequently used one is the residue and tillage management. And so I am selecting what type of implementation and picking from those fixed baselines. And so we are selecting from, we'll do, how about intensive till to a no-till or strip till, which is a type of implementation that is defined in these NRCS conservation practice standards. And so as soon as I add it from step 3, if I uncheck it, it populates step 4. And then now I can click the info button and I can learn a little bit more about how NRCS defines this practice standard, or I can look at the very simplified one-page summary of that practice standard and how that was implemented in Comet Planner. Which I'm not going to go into that now. Or you can just go ahead and start entering your acreage. So maybe I would like to do a nice solid number of, I would like to switch 100 of my acres from intensive till to no-till on non-irrigated cropland in Larimer County, Colorado. And you generate your on-the-fly reported values. So I could just switch this out with 400 if I wanted. And you're generating your on-the-fly emission reductions. And so it is categorized in terms of everything in Comet Farm is always, all of the estimates are always provided in terms of metric tons of CO2 equivalent, just to make sure we're comparing apples to apples. And in Comet Planner, the simplified version will give you the breakdown in CO2 and nitrous oxide. And we do still have methane in the hopes that maybe some of our accounting will include methane emission reductions, but our current standards do not include that. And so from switching intensive to no-till on non-irrigated cropland here, we're seeing a reduction in a 16 metric ton CO2e reduction annually. And then you can also download your Comet Planner report, which gives you a handy dandy PDF, which I would recommend doing because as soon as I refresh this page, or if I change my county, or if I accidentally exit out, you will lose all of this information. But granted, it did only take me about 10 seconds to put it all in. And so Comet Planner is just a quick and easy tool for users to generate a basic idea of what those emission reductions could be associated with conservation practice standard implementation. I would also recommend downloading your Comet Planner report, because you might notice maybe once a year or once every other year, you might see a slight difference in the same, if you were to run the same exact scenario, maybe 2 years from now, those methods might update. And as new literature becomes available, standards are updated, that blue book gets updated, then our methods are going to update as well. So you might see a slight change. So it is, I like to refer users to download it just so you know when you did it, when you ran the project, and then you can align with if we had any updates at that time. The last thing to demo is if you scroll down to the very bottom, we do have a abbreviated breakdown of how these methods were implemented. And then we do also show a detailed emission reduction. So if we think back to that cartoon that had all of those arrows on the picture, we do give you the soil carbon estimate and the other subsource categories broken down for each of these practice implementations. And so from the intensive to know till we are seeing that 15 metric ton reduction linked to carbon dioxide, which that is summarized. Any of the CO2s, soil carbon is included in that because everything is summarized in metric tons of CO2e. So we're seeing that the soil carbon, we're seeing the CO2 reduction is linked to an increase in soil carbon here. And then unfortunately, we do not have a way to download this directly from here, but I did mention that the entire Comet Planner data set is available for download, and those coefficients are going to be linked in there for all counties within the lower 48, and then a few for Hawaii. And then I did mention that we do have some trainings, which you can access the trainings for. The trainings mostly focus on Comet Farm because they last at least an hour of going through a detailed project. So we do touch on Comet Planner a little bit in the trainings, but if you're interested in Comet Farm trainings, we host weekly trainings for each of those accounting activities, as well as 2 different sessions of office hours. So if you go through a training and you're working on your own project and you'd still like to ask questions, sometimes it's easier to talk to a human than interacting from email. So we do offer office hours as well. And I think that was Comet Farm or Comet Planner in a nutshell.
Well, thank you very much, Haley. I have a couple of questions for you, if I may.
Yeah, you bet.
Can you speak in particular to what the value of this may be, again, for a farmer looking to track their transition to organic agriculture?
Yes, great question. So there are no specific practices in Comet Planner that are specific to or unique to organic farming, but a lot of the practices that are included and can be assessed for in Comet Planner are usually accompany the transition from non-organic to organic farming. In Comet Farm, users would have the ability to enter specific management that is included in your specific farm. So exact crops, the exact amount of manure or other organic amendments that you're adding to your operation. Comet Planner is relying on the fixed baseline that we built in that very large meta-analysis of Comet through Comet Farm. And so you can't get as specific in Comet Planner, but Comet Farm does allow for more specific data entry.
Mm-hmm. Very interesting, and I know it's probably very well worth taking the training for Comet Farm, but there are organic producers that are large acreage, plain states, maybe dry land, cereal and grain, something like that may be interested, perhaps starting with Comet Planner, going to Comet Farm. Another question is, once you get a report, are you able to then take that and does it give you guidance on what actions you might want to take for further sequestration? Like, how does a farmer interpret? What I find interesting is you're taking all this national metadata. A farmer can use it to then create some micro analysis of their field. Once that data is collected, what kind of action can a farmer take from that?
Great question. And so at the end of the report, that is really the end of where the Comet team kind of supports. But we do tend to recommend that based off of other users who have come to us, going to extension offices and NRCS offices, that we do have a lot of users who are going there to receive funding for certain types of practices that they're implementing. And a lot of those will bring a Comet Planner report with them to say, okay, if I do this, this could be my estimates on my field. And so with that, you could get funding from programs like an EQIP funding to implement cover crops or other practices that are outlined in Comet Planner.
So you actually might be able to get some funding from government programs encouraging carbon sequestration. I was going to ask about that, like kind of just a general term, carbon credit, so to speak, if that's, you know, an umbrella where something like EQIP falls in. I'm not sure, but that translates to real money. So I think
It does.
that's important. And then I would think that organic farmers may be able to benefit from that.
Yes,
Um,
definitely.
I
Haley,
think
there
we
was-
have a question. Allison, you want to ask this? Go ahead.
yeah, Marguerite has asked, does Comet Planner currently include the Organic Management Standard CPS 823? Or is there any plan to add this CPS?
Great question. So we do get requests a lot about this is not an exhaustive list of NRCS conservation practice standards. And unfortunately, the Organic Management 823 is not included in Comet Planner, but and there are not currently plans to add that because I've never gotten a request to add that to the tool. Adding practices to the Comet Planner tool are a little bit like chicken or the egg, in which in order for a practice to be included, one, it needs to be a CPS, NRCS defined practice standard, which this one obviously meets that qualification. There needs to be a request for it, which this is the first request that I've ever gotten for it. And then two, there needs to be data available, significant data available, which I am not privy to the exact number or exact amount of studies, but there needs to be data available on how that practice is implemented and like verification data or monitoring data of the impact of that practice being implemented. And then the final qualification of being added to the tool is NRCS has to provide us funding to be able to put that into the tool. But now that you have requested that, I can add that to our ever-growing Comet wish list and request that for future iteration.
So what does COMET mean?
Like the
acronym. Is it an acronym?
It is actually an acronym. And in the 3.5 years that I've been on the team, we have never actually used it. I believe some people will say, I've seen it actually linked on 2 different websites on USDA pages that it means carbon. Some say it means conservation. Management. I honestly do not know. We have sponged
I don't
it
mean to
from
put you on
everything.
the spot.
My mother would say it's for Haley's Comet, but that's just unique to her.
Hey, now that actually makes a lot of sense.
It does.
All right, so Haley, what's the website where people can go find out more about getting involved with Comet Planner, Comet Farm, and then we'll move on to Andrew, but give us where people can go to get more info.
That website is going to be comet-farm.com or comet-planner.com. And then I guess the last thing I do want to mention is there is a little need help widget that will follow you in every single page of Comet Farm and Comet Planner. And it is populated with a whole bunch of different frequently asked questions, which if you are still finding that not helpful, you can contact the outreach team, mostly me, directly through here with any of your questions.
Oh, well, thank you very much for your time today.
Yeah, thank
hey,
you so
we
much.
also had a person ask where you can find some of our past webinars. If you go to YouTube and you search for Compass Natural and TOPP, you'll find our videos. And this one will be posted there this week as well. Thank you again. Want to move on to Andrew Bish, again, last but not least, with some very important machinery for harvest. But when Andrew and I were speaking a little bit about this webinar while he was taking a road trip to New York, we talked a little bit, whereas Bish Enterprises specializes a lot in on-farm harvest equipment. Really, this kind of it's technology that's important from planting to cultivation, and we heard a little bit about that with the nano robotics doing some just subsurface soil cultivation. But I know Andrew's put some thought into this. Andrew, please, I'm very interested in your presentation as well.
Okay, well, thank you for having me today. And ideally, you can see my screen.
Yes, we can.
Fantastic. Okay, no technology problem. So Quick intro into myself. I am the Chief Operating Officer of Bish Enterprises of Giltner, Nebraska. I founded another company called Hemp Harvest Works and a co-founder of a fiber processor in Monte Vista, Colorado as well, Global Fiber Processing. I also serve in a number of nonprofit organizations. I am the president of the Hemp Feed Coalition, secretary of the Colorado Hemp Industries Association, and a treasurer of the Standing Committee of Hemp Organizations. Bish Enterprises, we've been around since approximately 1974. We're a multi-generational family business. My grandfather started the company. He was a farmer. My mother and dad own the company today. My dad farmed for a number of years. My uncles are farmers. I come from a long line of farmers, and today I help engineer and manufacture solutions for farmers and producers. So some of the challenges in transitioning to organic agriculture, before we get into looking at some of the equipment here, I want to talk a little bit about some of the advantages, but also what those challenges are, because I think that when you look at organic practices, while there are a lot of advantages, the challenges are high. Regarding advantages, environmental sustainability, improved health and safety, market demand and premium prices. If you're familiar with selling corn or soybeans into the marketplace, you can see market price on some of those products from an organic perspective. True of peas and just a lot of different products, vegetable growing as well. You do see a premium in that product, and a lot of that has to do not only because the product may be healthier for us, but there are some costs involved with that. You have higher levels of biodiversity, and there are some long-term benefits in terms of soil sustainability, soil health. So over time, organic becomes easier and easier and more like traditional agriculture. The challenge is oftentimes that transition period. So that, when we talk about several years, that's at least 3 years to convert a field into an organic field. That is a huge hurdle for a lot of producers out there. While people can receive premiums once they become organic certified, in that 3-year time period, you may experience lower yields. So you may actually have a crop that not only can you not sell for the higher premium price, but it might yield less. It actually will likely yield less than what you're currently experiencing using non-organic practices. Higher labor and management costs. Currently, we do see higher costs in terms of both labor and management. Now, the first presenter offered an opportunity to lower some of those labor costs by moving into equipment. But you're going to have that trade-off. You're going to have either a higher labor cost, you're going to have a higher equipment cost, but you are going to have a higher cost at some point during that transition at this point. The learning curve. I think the learning curve is a real challenge. Not only do you have to learn new techniques and strategies for managing crops, but you might not have a lot of data for what works well in your area. If we've not seen studies on organic, changing over to organics in a particular microclimate, it could be very, very complex and complicated. We see that somewhat in our area in Nebraska. We are a heavy chemical laden area, traditional agriculture, and some of the farmers that are transitioning in our area have struggled mightily with trying to figure out what some of the cover crops are that work, and different aspects of the organic farming that we don't know about in every single area. What works well in Pennsylvania, for instance, may not work well in central Nebraska, may not work well on on the Front Range of Colorado. There's a lot of variance there. Certification, compliance costs, that's another challenge to get over. And then I'm going to talk a lot about pest and weed control because once you're into the season, that is one of the real challenges we see in terms of organics. So first, again, before we get into equipment, crop rotation. This is going to be an important part of organic farming. It's not something we see with traditional agriculture. In a traditional corn, soybean neighborhood, for instance, you're going to see the rotation be between corn and soybeans. That's not an especially helpful rotation and doesn't necessarily provide much back to the soil other than you see where soybeans are nitrogen fixers and they provide that back to the corn. Although we often see an immediate need to inject more nitrogen, which reduces the efficiency of soybeans to provide that to the soil. So it's a big change in terms of what that crop rotation looked like. And if you're used to being able to just do a corn and soybean crop and you want to go into organics, that's going to be a real hurdle without the adoption of some of the other crops. And again, not all farmers are corn and soybean farmers. So you might be, a tomato farmer, and you transition out of tomatoes into another crop. You're likely going to be needing to add 2, 3, 4 other cycles of crops in order to get good and healthy soil conditions, which will minimize the amount of other outside applications. And since you're working with organic, you probably don't have a lot of outside application. So let's talk a little bit about the equipment. Some of the equipment's different. When we start to talk about organics, this is a conversation no-till versus high levels of till. Now, you can be full till and organic, and you can be no-till organic. You can be full till traditional agriculture or no-till. But when you're looking at or organic transitioning, we do see a lot of organic producers looking at how they reduce the amount of tillage, mainly to maintain healthy soil conditions, knowing that the opportunities to apply outside nutrients is a little bit more complicated. So the positive of no-till drilling is that soil conservation, no-till farming helps in reducing the soil erosion. Without the disturbance of tilling, soil structure remains intact, which is rich in organic matter, and nutrients are preserved. The negative, the weed and pest challenges. Without tilling, weeds may become more prevalent, requiring alternative methods of control. This sometimes leads to a reliance on herbicides, which don't align with organic farming principles. So here's what they call a crimper, and this is oftentimes used in no-till practices to terminate a cover crop. In traditional agriculture, you'll use maybe what they call a defoliant. Oftentimes that is glyphosate. Glyphosate is a very commonly used defoliant in the marketplace. Not necessarily safe. I think there's a lot of studies to show that it's not the best for humans, yet used very readily. So you change over to something like this, where you purchase a product like this crimper. This crimper essentially rolls over the crop, pushing part of the crop into the ground and ultimately damaging the crop to the degree in which that it dies. Now, that's an experiment, because some crops you have to apply more pressure than others. And if you don't do that and that crop continues to live after you've planted, you may have a crop failure. So the positive is here, crimpers effectively terminate cover crops without the use of chemicals. They create a mulch layer on the soil surface, which conserves moisture, suppresses weeds, and adds organic material to the soil. The negative is going to be that learning curve, and there is going to be a cost in this equipment. Now, if you're applying defoliant, you've got an equipment cost as well, but you probably already have that equipment purchased. This is going to be an additional purchase. Implementing a cripper requires an initial investment. Farmers may face challenges in adapting this tool and technique, and determining the optimal timing and method for effective cover crop termination. So that goes into that learning curve, that there's not one size fits all. There's not a chart when you get a crimper that says, here's the crop, and in your county, you need to crimp it at this many days, and this is going to be your result. We just don't have all that data yet. So that's one of the challenges to overcome. Here's a crimper combined with a no-till planter. Some of the advantage here is you're going to have less soil compaction. The positives here, combining the crimper and no-till on the same tractor allows for simultaneous cover crop termination and planting, reduces the number of passes in a field. That saves time, saves fuel, it saves soil compaction as you're only running over the field one time. Some of the negatives, it can be complex. Anytime you're running two pieces of equipment, they may not interact as well together. Maybe the crimper works better at 5 miles an hour and the planter works better at 3 miles an hour. Maybe, there's some of those things to deal with. So calibration and maintenance become crucial to use that type of system, and without having some inefficiencies. Now, after we planted in an organic fashion, we have to look at what are the mid-season cultivation options. So here's a product from a company called Einbach. Essentially, they provide effective weed control. This is going to be a tillage option. So it can effectively eliminate weeds between rows and reduce the need for chemical herbicides. It's what I would call a reduced tillage versus maximum tillage. The negative is equipment cost. You're going to spend some money on a piece of equipment like this. It's going to require regular maintenance. So that's going to be the trade-off where maybe you would apply a chemical. Now you're going to be purchasing a piece of equipment and using fuel to run through the field. And those are the numbers that you got to work out to figure out what those costs look like. Here's another example of a cultivator, just a different style. This is from that same company, Einbach. And the positive here, you get soil aeration, weed control. The negative, you could have excess soil disturbance. Anytime you're dealing with tillage, you do have to calibrate that appropriately. And the challenges in terms of maintaining that positive soil condition while also doing tillage become more and more complicated. So when you are, the microbial life on the topsoil is naturally going to be declining when you use tillage, but you have to offset that with what is the consequence of if that weed grows, and looking at what's cost effective. Is it more cost effective to allow some of these weeds to grow, or is it going to be more cost effective to disturb some of that soil? Those are the things that each producer will need to figure out in their location. Here's an interesting product from a company called A1 Implements. They call this the Weeder. This is a product you actually sit down on. So this is likely going to work in smaller farms, oftentimes with crops that aren't necessarily corn or soybeans, not grain crops, but maybe with fruit crops or vegetables. But this allows for a minimal till. So the idea here is you're just providing tillage where the weeds are, and you can control that. It's hand operated. But again, there is soil disturbance. It's gonna negatively impact the topsoil. And you constantly got to be thinking about how we maintain that microbial balance when using a piece of tillage equipment like this. Here's another way of dealing with weed control. One of the things I like about the flame weed control is there's no chemicals and there's very little disturbance of topsoil. So flame weeding uses intense heat to rupture plant cells, causing the weeds to wilt and die. The method eliminates the need for chemical herbicides, making it suitable for organic farming. What's one of the negatives? Well, obviously there's a risk of fire because it is a fire. There's fuel costs. Not only do you have the fuel of the tractor, but you have the actual fuel that's feeding the flame. You could start unintentional fires, especially in dry conditions. So those are some of the challenges with weed control, with flame weed control, as well as some of the positives. Let's take a look at laser weed control. Laser weed control is really, really cool. So you've got it's precision and chemical free. Laser weed control, and this is a weeder from a company called Carbon Robotics. It essentially identifies the plant and shoots a laser at it. It's very environmentally friendly to the soil. There's no chemicals involved. You pull it behind a tractor. Well, what are the negatives, right? So you've got that high initial cost and then energy consumption. It takes a lot of power to run a laser weeder. So how does that math work out on a per acre basis? Those are the things that still need to be sorted out, although there is some data in some crops that they've ran for multiple seasons and getting a better handle on that. You do have fuel costs. Now, some of these items are self-propelled, but you may have to pull it behind a tractor. So if you're pulling it behind a tractor, that's going to use fuel. If it's self-propelled, it's likely not powered by solar. It's going to have some sort of fuel source, and that's going to be a cost as well. Here's another option for cultivation. And the reason I have brought up so many options for cultivation is because that is one of the biggest challenges in terms of equipment, is how are we going to handle the weed control. So this is a robotic pull behind weeder. It comes from a company out in Salinas, California, named Stout Ag. Really cool product. I would call this minimal till. It uses sensors to identify the weeds versus the plant. And it actually has these little fingers that run around and are kicking up the weed. So they're trying to disturb the soil where the weed is. They're trying to minimize soil disruption around the plant. Again, these things are expensive. And when I say expensive, I don't mean like $20 or $30. I mean, a system like this is going to be $250,000 out of the gate. And at $250,000, it's not going to give you 30 feet wide of weed control. You might spend $250,000 for 8 to 10 feet of width. And so you're looking at $250,000 for 2 to 3 acres an hour of performance. Now, if you don't have a lot of other solutions, you have high labor costs, this might be effective, but those are some of the challenges with products like the robotic weeder and the laser weeder that I just showed you. Here's an interesting option that's not very well been adopted, although you can use this in combination with equipment. You can provide beneficial insects in via drone. We've seen some companies do that. Little robots that can run through the field are capable of doing this type of thing as well. So that's another use for robots. This is a way to help reduce a lot of the pest control. Now, when we talked about pressure from plants, but you're also going to have a lot of pressure from insects when you're working organically. So how to solve that? There's a number of ways to do it. This just happens to be one that I put up here. We also see people putting pollinator barriers, which help bring some of these insects in borders around the fields. And that's a somewhat effective way of dealing with bringing in beneficial insects without having to actually buy insects and bring them in, because it is hard to purchase insects and then apply them effectively to an area. Not only that, you have to make sure that you're bringing in insects that are native to your area. You don't want to screw up the ecosystem by bringing in a bunch of insects that really shouldn't be there, and either outperform other insects, creating challenges, or underperform. Neither of those situations is good. I think pollinator barriers bring naturally beneficial insects to organic fields, and that is not a new idea. That goes back hundreds and thousands of years. If you look in places where neem grows naturally, Puerto Rico, for instance, you see where they oftentimes will plant neem trees in the vicinity of crops to reduce some of the insects that would naturally destroy the crop otherwise. I did not provide anything relative to harvest and organic, and the reason, well, that's my specialty that I work in. Let me stop the share here. There's not much special equipment for transitioning once you get out of mid-season cultivation. Most of the time, expense, cost is going to go into that either the planting phase, I would say pre-planting, planting, and then mid-season. Once we get into harvest, traditional equipment is typically used. Although you might have, depending on the crop itself, you might have equipment that needs to have stainless steel versus regular steel, things like that. But it's pretty minimal when you start to enter harvest. So that's just a sampling that I wanted to provide there of what transitioning looks like in terms of the differences of equipment. Most of those items that you see there are just not used in traditional agriculture.
Andrew, thank you very much. That was very well thought out, and I really appreciated how focused in it was on organic transition considerations. I would think, as you mentioned, with harvest is harvest, but then again, organic considerations do come into effect with a lot of the post-harvest handling of crops and products, and we hope to get into that in some future topics. I really also liked your thing about crimping. I learned a little bit of that. I saw a talk from Rick Clark, who's runs 7,000 acres in Indiana, no-till, regenerative organic, using crimping as a primary method of getting that cover crop, turning it into, like you called it, cover crop termination, getting it into a mulch to help control weeds. So I think that's really effective. The other thing that I think is really interesting that you brought up is all the innovations in mechanical weed cultivation, because that is probably one of the primary challenges that organic farmers have to face as they're transitioning, is how do they tackle the weeds, since they can't really rely on glyphosate, which, as you mentioned, is actually the most widespread pesticide ever in the history of humanity that's been applied to this planet, so much so that it's in the rain, it's in the groundwater during the application season. And you're kind of right there in the center of it in Nebraska, a lot of the pesticide and GMO agriculture. Another point that I thought you brought up was a lot about the learning curve. So I think this TOPP program, which provides some good resources and education for growers thinking about this, is important. And what's also been really important, and I've been out a couple times out near you, are the Vetter family, Dave Vetter, who gathers farmers every year to literally exchange information one-on-one in a community. And, when I was out there, that the question when you brought up about rotation is, hey, what's your rotation? So farmers talking to each other in organic has always been really, really important. A question for you: have you been able to see, as you work with farmers between conventional and organic, any differences in soil health Andrew?
Yeah, I mean, in general, we see a dramatic increase in soil health when working with organics, and not just organics, but when you start to enter the no-till realm, it gets even better with organics. But no-till plus organic, you start to conserve topsoil versus lose topsoil. Most areas in the country that are doing traditional farming are losing topsoil. Organic producers, no-till farmers are adding topsoil. That's a major difference. So when you look at microbial soil health, it's considerably better in no-till and organic environments than you will see with traditional agriculture. What a lot of people don't realize, especially when you look at nitrogen application, for instance, nitrogen is interesting in the way that when you apply nitrogen to the soil, it actually prevents nitrogen from coming to the soil naturally. So the soil will ultimately make nitrogen in small amounts, and depending on what the crops are that are there, you'll have more nitrogen or less nitrogen if it's a high nitrogen fixer crop. But once you start to apply nitrogen to that, you see it stops. A natural nitrogen production stops. And so you really have most of our fields in the central US are what I would call dead fields. They can't sustain themselves without the injection of outside chemicals or other products like nitrogen to the soil.
Wow. That's fascinating. So it's like a bigger hurdle for them in a sense to get over that and perhaps transition to, and I won't even say organic, but just reduced till, no till, where we can start rebuilding the soil again. And I think that's important all over America, actually. So thank you again for that. Allison, did you want to open up to some other questions? Did you have any yourself? And let's bring our speakers back as well, because maybe they have some questions for each other.
Yeah, I'm going to allow all of our attendees to chat and open it up to whoever you'd like to ask some questions to.
Well, Sarah Hinckley, Haley Nagel, Andrew Bish, and my colleague Allison Oliver Salvati. I mean, this had it all for me. I mean, we were talking about nano robots, we were talking about drones, we were talking about flame throwing weeders, and we even started talking about laser weed control. So I think this is all very cool stuff, and it's only tapping, as far as we know, all the technology that's out there. I have a question regarding the Comet Farm, actually, Haley. Are you able to combine some of that, metadata and the micro analysis with perhaps farmers may actually be using some on-farm measuring tools or smartphone apps as well? Does this combine with other applications for farmers at all?
Great question. So we recently, or we are just about to finish our work with the interoperability between Comet Farm, which is the more complicated version of the Comet tools, an API accessibility between them, and Farm OS, which is OpenTeam's kind of farm management tool. And so we are working with that. We also currently have in development, not officially part of the Comet team, but CSU and our team, or Keith Caution's lab, is working on developing a carbon farm planning portal and a verification portal as a part of a partnership for Climate Smart Commodities group, which would have further integration and allow producers or conservation planners to develop carbon farm plans and integrate that Comet data in there as well.
Anyone else want to speak to that, combining, because I've heard a little bit about how farmers in the fields now can also start entering data on, basically on tablets so that they can be capturing real-time info. Nobody? That's fine. Otherwise, I believe we have some questions out there. Jason, you might have a question, but you're on mute.
How you doing? This is Jason Wallace. I actually, I appreciate you recognizing my hand. I had asked a question in the ask a question section. So, I'm just curious, in addition to the question I asked about sort of the YouTube channel or central location, I was also wondering if any of the panelists have perspective on the use of hemp for soil remediation in urban settings.
Andrew, that's like a softball question over to you from what you know about industrial hemp.
Yeah, that's a good question. So what I haven't seen is a lot of data on that, but there's been discussion over the past several years. Naturally, I would expect that it would work well. To what degree we see the reduction of heavy metals in the soil on a per year basis, that's something that I don't see a lot of data out there on. So I know that there's been some places that have tried it. I know there's interest, for instance, in doing this just outside of Denver, that facility that's got a lot of nuclear waste. But I don't have a lot of data to answer that question. But from the data that is out there on that particular subject, I would expect it to work very effectively.
And then as a follow-up, and to better frame that response, I appreciate that. What is the sort of time frame for measurable remediation? Is it generally you're seeing a change in soil quality within a growing cycle or two? And the other factor in terms of effectiveness for hemp or other question is just regarding the needed space, because it, to my understanding, is a taller plant. Does it need more space than can really even be provided in an urban setting? For example, the footprint of a row home or, an apartment building. That footprint, is that a large enough space to really grow enough of the plant for it to effectively remediate that soil?
Yeah, that's an excellent question. I would say that I don't know the answer to that. I wouldn't say that it's too small of a space. I think the question becomes, how much material in a square foot, for instance, can be pulled out in a year with a hemp plant. I don't know that. I think that's where we've got a lot of room to do some additional research. One thing I can tell you, coming from an area that is saturated with heavy metals in the soil, especially with in the ditches here in Nebraska, we have a lot of feral hemp. And when we have done testing on the feral hemp, the heavy metals that it absorbs are through the roof. I've got some COAs I could share that it's startling the amount of heavy metals that are in the plant. So you can tell that the plant is doing a good job of absorbing that. The question that you have, which is good, is at what rate is the absorption occurring? And I'm not sure where to find a study that has that data yet.
I mean, that's an interesting, topic also in terms of, part of transition to organic is, looking at the soil if you have to remediate it in any way. And then the question comes for me again, what do you do then with that crop that sucked up all that lead or whatever it is in, urban soils? So those are some questions that come up for me. Anyway, I want to thank everybody for being here today. I want to thank the USDA Transition to Organic Partnership Program. I want to thank all the supporting organizations that have helped us put this together, and that includes our speakers here as well. Thank you for taking the time with us today. This content will be available on our YouTube page. You can find that by searching for Compass Natural and TOPP. I actually also just put the website link into the webinar chat. You can learn more about our event, in-person event at the Colorado State University Spur campus. If you haven't seen that campus, it's right next to the National Western Stock Show Complex, and it is an amazing campus, state of the art, and that's where we'll be hosting our live event. And we'll have some of our speakers from today's program participating in that as well. So thank you, Sarah Hinckley. Thank you, Haley Nagel. Thank you, Andrew Bish. I learned a whole lot in this session today. And again, I realize we're only scratching the surface. And again, thank you to USDA for enabling all of this programming. You all have a great day, and hopefully we'll see you in Denver on November 9. And also in 2024 as we continue to present webinars helping educate farmers curious about the environmental and economic benefits of organic food and farming. Thank you, guys. All right,
Thank
y'all
you.
take care now.